In this video, we're going to do classwork 3.1, number 6 and 11. So let's start with number 6. So in this case, it says that we have a ball and it's attached to a cord and it's being spun in a horizontal circle on a frictionless surface. So the mass of the ball is 0.4 kilograms. The radius of the circle is 1.3 meters. And it says that if the string, so if we just kind of draw a picture of this thing, okay, a rough picture because I have horrible artistic skills, that here's the ball and it's a string and it's going around in a circle on this frictionless table, okay? It says if the string exceeds 60 newtons, then it breaks. So the maximum force or centripetal force that we can have is 60 newtons. And it says, well, what's the maximum speed, or what would the speed be going with the maximum force? So we're trying to find V. So again, this is pretty simple, just plug and chug problem. We've got centripetal force equals mv squared over r. Okay, so 60 newtons is equal to the mass of the thing turning times the velocity that's going squared all over 1.3. So we just take 60 times 1.3, divide it by 0.4, and then we take the square root, and we get 13.96. So the velocity of this thing is going is 13.96 meters per second. Okay. Now the next part of the question is pretty interesting. It says that how would your answer be affected if there was friction? Okay. So really what we've got to do is we've got to look over here at our picture, right? And think about what is the force that's causing this thing to turn. The force that's causing this thing to turn is the inward force, the centripetal force, which is the force due to tension. Now, as the ball sort of slides along the surface, at this instant, its velocity is tangent to the circle. So its velocity is in this direction. So again, its friction would be in this direction. Okay, so the friction would oppose the motion. So here's force friction. Okay, now if we look at this, we can see that from the picture, the tension or the centripetal force is actually perpendicular to the frictional force. So it is not going to affect the acceleration of this ball whatsoever because it is in a completely different plane from this. So the maximum velocity would not change. There would be no effect because the force, this force, is not going to add anything to this force because they're perpendicular. All right, so let's go ahead and then look at a problem now that has an example where friction is actually the force, so friction comes into play in the centripetal motion, okay? And this one's really important because this is going to be pretty similar to the lab that we're going to be doing, okay? So this is number 11, and it says, a coin is placed 11 centimeters away from the axis of rotation of a turntable that has variable speeds. So the actual radius is 11 centimeters or 0.11 meters. When the speed of the turntable is slowly increased, the coin remains fixed on the turntable, okay, until a rate of 36 RPMs. Okay, so at 36 RPMs is when it starts to slip off the record. What is the coefficient of static friction for the coin? So we are asked to find the coefficient of static friction. So we're not really given a lot of information here, okay? But with just this small amount of information, we can solve this problem, okay? So let's just go ahead and talk about, what forces are at play here, right? So we have a record player like this, and we have a coin over here, and the radius is 0.11, and it's spinning around in a circle. So the question is, when it's sitting on that surface, what is causing the centripetal force? Well, if you're just sitting on a surface and it's the friction that is preventing it from sliding, okay? So it's actually friction that is causing the mv squared over r. Okay? And in this case, it's static friction. So we know that static friction is actually mu s Fn is causing the mv squared over r. And we know that Fn is mg because we're just sitting on a flat surface. Mu s mg equals mv squared over r. And if we look here, it's important to note that this m and this m are the same. The m of the coin is what is in the friction equation, and the coin is also the thing that's doing the turning, so the m's actually cancel. It's important to think about that in terms of what mass what m this really is. So it does cancel in this case. And then if we just want to get g or mu s by itself, we can just divide by g. So we actually get that mu s is equal to v squared over r times g. Okay? So we have the radius, we have gravity. What's missing? The velocity. So somehow we need to be able to use the other piece of information that we've got to solve for velocity. Okay? So remember that 36 RPMs is a revolution per minute, which is a frequency measurement. Okay? So it's in minutes. I want it to be in seconds. So that's really the first step. So I'm going to divide 36 by 60. And if I get that, I now know that this coin is actually going around at a rate of 0.6 revolutions every second. Okay? Now, this is frequency, but I want velocity. Okay? So if it can go from here all the way to about here in 1 second, I just want to know how many meters is that? Or what is that distance? Because if I know that distance, that'll tell me meters per second, right? If it takes this distance for a second, that would be the velocity. So we just need to figure out, well, how far is it 0.6 away around? Well, in order to know that, we need to know how far it is all the way around, and then we just multiply that by 0.6, and that will give us our velocity, okay? So 2 pi r is how we find the circumference of a circle, or the distance around the outside of a circle. So it's going to be 2 times pi times 0.11. Okay, so on this calculator, where's pi? There it is. Pi times 2 times 0.11. So all the way around the circle, the entire circumference is 0.69. Okay? However, we only want to know 6/10 of the way around, or 0.6 of the way around. So if I take 0.69 and I multiply that by 0.6, it gives me a distance from here all the way to here of 0.44, or 0.41, excuse me. So this is 0.41. And since it takes it takes 1 second for it to go that far, then we know the velocity is actually 0.41 meters per second. Okay? So it makes a lot more sense if you just reason it out and use your common sense than trying to memorize another equation. You know, you can memorize that if you take frequency times the circumference, it'll give you the velocity. However, you're going to have so many equations in your brain by the end of this year that any tool that you can use, just use your common sense and skills that you already have to solve a problem like this, rather than memorizing another equation, is going to make your life a lot easier in the long run. Okay, so now we have everything that we need to plug in, right? We're trying to find the coefficient of static friction, so we need to take 0.41 squared, divide it by r, which is 0.11 times 10, and that will give us the coefficient of static friction. Okay, so 0.41 squared divided by 0.11 divided by 10 gives me 0.15. So the coefficient of static friction is 0.15. And remember, it doesn't have a unit. Okay. Another thing I want to mention is just remember that coefficients of friction are typically less than 1. Okay, so if you get an answer for a problem like this and it's like 2.5 or 53, anything other than some fraction, then you know that you probably have done something wrong, and you can go back and double check yourself.